Hello, today we are going to solve a set of questions. Let me start from question number 1. Let's go through the question itself. The diagram shows an object P undergoing a uniform circular motion. So it's a uniform circular motion. So now the question is, which arrow shows the direction of the net force acting on object P? So let's go here. So we have a circular motion. Let me use a circle here. Right, okay. So this is sort of the center of the circle. And this is point P. Right. We know that if we have a uniform circular motion, the speed is not changing while velocity is changing. And the reason is behind these facts is that the speed is a number or a scalar, while velocity is a vector. And here the vector is like once in this direction, that means a different color. Once is in this direction, and after some time after some t, if it goes for an angle of theta, the object P will move to a new location, and in that new location we will look here, right? So we see that the velocity, which is tangent to the circular motion, which is tangent to the circle, basically is changing its direction. So at time t1 it was here, and it was v1 after time which is passed for theta. Let's say it's time t2, we have gone to point v2, right? So we know that the acceleration, the centripetal acceleration, is actually can be defined. I mean, this is actually general, not just for centripetal. This equation is actually general. And if you take the ratio of the delta v, which is the difference between the velocities vectors over time delta t, and if you set delta t to go to 0, you find the acceleration actually. But in this case, since it's a uniform circular motion, that we will see that this turns out to be a centripetal acceleration. Now we know that delta v is literally v2 minus v1, and we sort of can just by imagining that this can be written as also v2 plus minus v1. So it's actually we can watch it as sum of two vectors. So v1 we can just reverse it from here, sort of v1, and then if I pick and then basically a would be in this direction, on yellow direction, toward the center of the circle. So if I want to draw here, so basically this is like v2, and then you have v1. Actually it's like minus v1, because the v1 is downward and minus of it is watching upward. And then v2, you start from the beginning of the vector, come to the end, and then minus v1, you go up. So this will show you the v2 plus minus v1. So this is basically the direction of your centripetal acceleration. Sorry, I have forgotten to put the vector sign. Actually, this is also vector, because on the right hand side we have vector, on the left hand side you should find vector as well. So this means that at every point that the object P is, if we find its acceleration on a uniform circular motion, it always has its acceleration pointing toward the center of the circle. So, since in the question it was asked about the net force acting on V, you know that on a circular motion, the net force by some, we can put it as MAC, right? We can watch it like this. So the net force basically is also in the same direction as the centripetal acceleration. So we can tell that at point P as well as, we can call this point like, the object P at point, let's say, like small p1 and small p2, and we call it this capital P. So at point p1, similar to p2, we will have something like inward toward the center of the circle. So I think the answer is now clear, that when we have this situation, the Y would be the right answer. Basically, C is the right answer. Option C, which shows Y. And that's because it's just a uniform circular motion.